Hello, everybody. Welcome. My name is Whitney or Whit. I am a GMAT, Jerry, and EA instructor with Manhattan Prep, and super excited to get to be hanging out with y'all today. Before we jump into our session topic, I'd love to hear from y'all. Where are y'all all coming to me from? How's your day going? So just tell me a little bit. Hello. I see some messages from GMAT Club, but what about the rest of y'all? Where do I have guests coming to me from? I'm in Durham, North Carolina, by the way. So I'm right up the road from Duke University. For those of you that are considering Fuqua School, it's right here up the road. Where else are y'all coming to me from? Where else? Hello. All right, Ayush, welcome. Very cool. Oh, I've got Goa, India. Beautiful. Good evening, then, to many of you. It's just before noon here on the East Coast, but excellent. Well, my hope is with that 740 GMAT Quant 49, what we're going to talk about today will help make that 51 much more of a possibility. Great. I've got more coming in from India. Excellent. So do tell. So Ayush, I know you've got the 740. You're getting ready to take the test on, by the way, my birthday. So that'll be great. But how about the rest of y'all? When are you taking the test? Oh, Karosh, great. I'm glad I'm the best. No, I appreciate that. LA, good morning. Good morning to you. So when are y'all taking the test? Oh, Colombia. Oh my gosh, save me some arepas and some buñuelos. Yes, please, Sandra. That would be delicious. You'll have me starving by the end of this session. Welcome. When are y'all taking the test? I got to limber up those fingers because I'm going to ask y'all a bunch of questions today, and I want you typing in your answers. So we're getting a warm up here. When is everyone taking their exam? So I know that Ayush is taking the exam in just a week, which is awesome. A little over a week. Sandra, Karosh, how about y'all? When are you taking it? And I've got a couple of folks. Let's see, October. Okay, cool. Getting started. Priyanka, nice. Planning for the next 2 months. Excellent. Well, we have some advanced topics that we're going to cover today. Right? Ooh, lots of August and Septembers. Yes. Oh, Varun, nice job with the getting really ahead on this. That's excellent. That's excellent. Well, I want to get us going because we have a lot of cool stuff to cover. We're going to be talking about some of my favorite concepts today. We'll talk about advanced statistics. And what I love so much about this area is that it's not just useful for the test and for getting that 51 quant score that many of you are looking for, but these are techniques that are going to be useful for you once you go to business school. So understanding how different distributions work, or thinking about skewedness, or even understanding complex averages, being able to read from charts and diagrams. This stuff is going to help. It's also a really nice way to start to think about visual representations of problems as we work, right? So today, let me share my screen so that you can see we are talking advanced statistics. Now, these advanced statistics will play out in multiple choice questions. We will also see some data sufficiency questions today, and we'll see a couple of integrated reasoning questions as well. Yeah. So as hopefully everyone can see the screen, right? Lots wrong. So we're going to be working on this, but here we go. We'll start in today's session with some quick descriptive statistics. So having your little fingers working as quickly as possible will help. We'll then move into the concepts of some weighted averages that then take us into complex median concepts, as well as skewed in terms of distribution. We'll look at standard deviation and the rules that you'll need to understand for that for the test, and then a little bit of a cautionary tale on what happens when we mix statistics. So I want to start. Let's type as fast as we can. What is the formula for average? So how do we calculate the average? What is that we do to calculate the average? What do we do to calculate the average? Yes, beautiful. So our average is going to be the sum of a bunch of terms together divided by the number of terms. Great. Okay. What about median? Help me out, y'all. Type it to me as fast as you can. How do I find the median of some set of numbers, of a list of numbers? How do I find that median of a list of numbers? Yeah, it's the middle number. So the first thing I'll have to do is I have to put them in order. And once they're in order, I'll find the middle. Now, what happens if I have, oh, beautiful, Karosh, it's as if you were reading my mind. If I have the list 1, 2, 3, 4, 5, the median is 3. If, however, I were to eliminate the 5, the median is going to be the average of the two middle terms. Beautiful. So I can put it in any order I want, but the median is the physical middle. So when we think about an average is where the weight of the set is kind of equally balanced. It takes into consideration really big outliers or really small outliers. The average kind of holds that center point of a set. When we look at the median doesn't care about those extreme values. It just cares about what's the physical middle, where 50% of the observations are on the right and 50% of the observations are on the left. All right, hit me with range, y'all. What is the formula for the range of a set of numbers? There we go. So my range is going to be my largest minus my smallest. Beautiful. So in this set of 1 to 4, the range would be 4 minus 1 is 3. Mm-hmm. And then standard deviation, last but not least, what do I need to know about standard deviation? And side note, it is not a formula. So just tell me in like a word or two, what does standard deviation generally mean? So when we think about standard deviation, what concept are we considering? What is our beautiful job, y'all? Nicely done. This one's hard to put encapsulate into one word, right? What is standard deviation? Yeah, it's sort of like, I love this. It's how far things are in general from the average. So how are they distributed within a set? Are most of the numbers really far from this average? Are a lot of them very clustered? And so one way we can think about standard deviation is to consider the concept of spread. So how spread out are the numbers? Range on the GMAT can be a good, proxy. That the wider the range, the more spread out. But we also want to consider the values inside of the set as well, not just the endpoints. So average and median are both trying to get us at this measure of central tendency, like where's the middle. Range and standard deviation is helping us understand the spread or distribution of a set. Yeah. Now, another great question came into the window about mode. I've never seen the GMAT use mode, but mode does mean the most frequently occurring number in a set. And so Jaideep put a great set in the window of 1, 1, 2, 2. That would be a set that has two modes. It has a mode at 1 and a mode at 2. And so anytime we've got any number that shows up the most frequently, there could be 4 or 5 different numbers that show up that many times. If there are multiple numbers that all show up 5 times, then all of those numbers would be modes of a set. So not all sets have a single mode. In fact, many real world sets have lots of modes. Yeah, great question. Great question. Okay, so got me so far on our big descriptive statistics. So now let's do the real work. We'll talk weighted average. So in order to understand the concept of weighted average, it can be useful to think about averages in general as a again, this idea that I want to make sure that the value, the sum of the values on one side of my average is equal to the sum of the values on my other side of my average. So median, the number of values are the same on both sides. Average, the weight of the values is the same on both sides. Yeah. The mode, you could either say has no mode in that case if everything shows up once, Neha. But again, for the GMAT, I have never seen a mode question ever. Like not once, not in a book, not on the tests. So I would not worry about mode too much. So let's talk weighted average. We'll start with a relatively simple version of weighted average. So for this version, hit me with your answer. What do y'all think Anna's final quiz average happens to be? What is Anna's final quiz average? So on half her quizzes, she gets 100. Other half, she gets a 90. Where does that land her at the end of all of these quizzes? Nice, y'all. Nice. So I'm seeing some answers pop up. I'm also seeing a little algebra getting done. And you're exactly right. I've got half of her quizzes at 100, half of her quizzes at 90. I could think of it as 50% and 50%, or I could apply some numbers to see how it holds. Like, let's imagine she has 5 quizzes and she scores 100 and 5 quizzes and she scores a 90. The formula traditionally for weighted average is that I just take the weight, so half times that amount, right? So I'd take 1/2 of 100, and then I would add the weight times the other average. So this is average of the first subgroup, average of the second group, and then I would divide it by the sum of the weights. Easy enough math here, right? So I add 50 plus 45 and over 1, and so I get 95. Okay, great. That's fine. But what I'll say instead is that instead of thinking formulaic, weighted averages are going to be a lot more powerful when we think about them using a visual. So I'm going to start to talk a little bit about this concept of a tug of war. So who's familiar with this idea of a tug of war where you've got like a rope and a flag in the middle and the people on each end are like pulling and trying to win? Right? Give me a yes or a thumbs up if you're like, yes, tug of war sounds familiar. That feels like something that I was forced to do as a child. That was not an enjoyable game, right? But we're thinking about this like push and pull. So I want to make sure that's an analogy that, like, for the most part, we can all buy into, right? So I've got this tug of war pulling me in both directions. Yeah, cool. Squid Games. There you go. I have thankfully not seen that show. That thing looks terrifying to me. So what we'll think about when it comes to this world of weighted averages is this tug of war, okay? So when you think, is this a weighted average problem? What I'm looking for is I'm looking for 2 subgroups that have the same quality or the same thing, the same measurement being taken. So I've got a group of tests and the measurement is being taken that gave them 100. There's also a group of tests and the measurement taken gave them 90. And then I want to know something about those 2 subgroups put together. So the visual, and we're going to get a little bit of quick practice with it. The visual for this, or that I like to use, is this kind of tug of war with 2 opposing ends. So it'll end up stacking up that on each end, I'll have 2 pieces of information. And then I'll have some piece of information that goes in the middle. And where that lives in the middle, it'll depend on the problem. But I'm going to think of this from left to right. So if I know that one of the qualities is 90 and the other is 100, I'll usually put 90 on the left and 100 on the right. So thing to note, what goes across the top is the metric that is being averaged. So in this case, it's a score. A test score is what we're averaging, so that's what goes up top. On the bottom would be the number or weight of each group. So she said 50% were a 90 and 50% were at 100. The thing to note about this 50-50 is that when I think about the weights of a problem, the values themselves are irrelevant. I don't care that it's 50 and 50 in terms of how I'm going to compute the average. I wouldn't care if it was 5 and 5 or 10 and 10 or 30 and 30 or 1,000 and 1,000. The actual numbers don't matter in computing the average. The ratio of those numbers is what matters. And so the ratio here is a 1-to-1, which means in my tug of war, we are at a stalemate. The 90 and the 100 are both pulling at the same resistance. And so the flag is going to land dead in the center. And so I end up here with an average score that is halfway between my other two. So I've got my average halfway between. What I'd like to do then is let's try this same problem, right? But we'll do two little quick variations on it. So, and I'm going to put both of them on the screen, and I want you to try both variations. And then submit your answers to both when you finish them. So I'll throw a couple of minutes, minute and a half on the screen for y'all to try. Give these two versions of the question a go. And I know that you could do them with math. Believe me, I promise. I know that you can do these with formulas or what have you. But I want you to see, could you set up this chart and at least figure out roughly, maybe not exactly, but roughly where the average would be, right? So we'll try it on the two sides. And then I'll throw a little bit of a timer up for you, and then we'll talk about it. All right. And we could talk about that one in a little bit, Jaideep. That's a great question. Hopefully everybody else can still see the screen. Is that the case? Can folks still see the screen? I know, Kriti, it seems like you've got some issues with the technical stuff on your end, but I just want to make sure that's not on my end. Very nice, y'all. Very nice. So again, given the simple math, right, the very easy numbers in this case, I think solving it with algebra totally works. That said, I still want us to practice how this over-under tug of war can play out. And so let's try it for these two. So for the first one on the left, I'll draw my little, tug of war. And I've got my 90 and my 100 again. This time it's 25% of her quizzes at 100 and 75% of her quizzes at a 90. If I reduce this is really the same as a ratio of 3-to-1. So for every 3 scores of a 90 she gets 1/100. I could immediately use these numbers and calculate if I wanted to. I could absolutely calculate if I wanted to. But what I think can be a really fun way to solve these, especially as the numbers get ugly and my calculator is nowhere in sight because we don't have one. What I want to see instead is, where would the flag on this tug of war be? So if 90 is pulling with a weight of 3 people, the flag is going to be somewhere over here to the left. So at a minimum, I know that the answer is going to be less than 95. So before I do any math, I would check my answer choices and see, are there more than one answer, or is there more than one answer between 90 and 95? If not, I pick the one, off I go. That said, what I know about this is if I think about a total, so 3 parts 90, 1 part 100, that's 4 parts. I'm pulling, the 90s are pulling the flag in their direction 3 units, a power of 3 units. So you can almost think about breaking this line up into, it pulled at 1, 2, 3 bars to the left, whereas in the 100 is only able to pull 1 bar away from the 90. That's where we get a line that's then divvied up into 1, 2, 3, 4 breaks. And so if I try to calculate like a number line where this would be, to go from 90, 95 would be in the middle. So 92.5 would be on the left. So the correct answer is 92.5. We can move through that exact same thing relatively quickly for the second one. So once again, I've got 90s and 100s. This time though, it's 80% on the 100s end, 20% on the 90s end. I'm going to reduce those to a 1 to 4 ratio, or a total of 5 parts. That means that the 100 has pulled this 4 spaces its direction. 1, 2, 3, 4. Whereas the 90 has pulled it only 1. And so I've got to figure out, if this were a number line, the breaks from 90, this would go 92, 94, 96, 98. And so the correct answer for the second one would be 98. Nicely done, y'all. Very nicely done. All right. So what happens then if we get to the part where this little back and forth is actually really powerful, where the middle number is what's given, not missing? Okay. So let's try this one. And again, see if you can think about setting it up. But now I know the middle number. So could I use that same idea of how far something has pulled, how many units it's been pulled in each direction? Can I use that to figure out some of the underlying pieces? Let's take 30, 45 seconds. See if you can get it set up for that. Beautiful. Very nice, y'all. Very nice. Very nice. So if we set up our little number line, I've got some 90s, I've got some 100s. This time I have an average that I know it's 96. So it's going to come in right here. And I've got, she got 100 on the first 6. The question is, how many total did she get? So what I'll look at is, I'm going to look at this like pull strength. So we are, right, the 90 is going to be fewer than 6. So I already know that. Though the 96 has been pulled towards 100. So whatever goes under 90 is going to be weaker than the 6 that's under the 100. But the 90s, that 90 end has pulled the average away from 100 4 units. The 100 end has pulled the average away from 90 6 units. So the 100, according to this, has a power of 6, whereas the 90 has a power of 4. Turns out that I've already listed the 100 as having a power of 6, and that means I can literally just create 4 for this one. And my answer, 10. Nicely done. Not too bad. Okay, so we step up the difficulty a little bit. Right? What if we add the following hiccup? So So we'll add this one here. Give that one a go. And again, we're looking to try and get answers to these in like 45 seconds to a minute without a calculator. I like it, increasing the difficulty a little bit. Here we go. A little more challenging for this one? What do you think? Did I do good? Did I step it up? Did I step up the difficulty a little bit for you? I hope so. I hope so. I've got some guesses coming in, which are great. So let's start with where these numbers would go. So I'm going to build out my little line. I'll stop my timer too. Yeah. So we've got 90 on one end. So she's got on her first 10 quizzes, she scored a 90. And then she's going to have 5 more quizzes. I don't know what she needs to score on those, but the goal is to get a 92. Well, I know that if she's got 10 tests at 90 and only 5 tests at this other score, the sort of star is going to be over here. And in fact, I can reduce this. This is back to my 2-to-1 ratio, which means if they're in a 2-to-1 ratio, if I think of the total, that means I can divide up my tug of war line into thirds. So this will pull 2 units its direction. This is going to pull 1 unit its direction. And so this right here is where my 92 lives. So if this little asterisk mark is the 92, then 90, 92, 94, 96 is my correct answer without having to do any real algebra. Thank goodness. Thank goodness. All right, last but not least. Last but not least, let's try one more. Here we go. And then we move into the real challenge. Yeah, you start to move into what these look like in real questions. All right. I'm excited. I stepped it up a little bit. Awesome. Okay. Very nice. Very nice, y'all. Very nice. Okay. So if we set up our little, let me scooch this out of the way a little bit. If we set up our little over under E sort of tug of war, she earned a grade of either a 92 or a 100. She took a total of 16 quizzes, and her overall quiz grade was a 97. All right. Well, the 97 implies that the 92 pulled the average 3 points its direction. It also implies that the 100 pulled the average 5 its direction. So underneath the 100, I get this weight of 5. Underneath the 92, I get a weight of 3. So my overall weight in this universe would be 3 to 5 to 8, but I have to double that to get to my actual 16 tests because I'm only going to think about this as ratios. So if I take this to a ratio of 6 to 10 instead of 3 to 5, then I get my total of 16. So how many quizzes did she score 100 on? 10 of them. Okay. All right. So you ready for a real question with real answer choices? I hope so. So let's use the real answer choices to see if we can make the world a little faster and easier. Yeah, that works too. It's that sort of 2 to 1 kind of ratio. Mhm. Yep, you can do it the same way. Yep. Here you go. Nice, y'all. Perfect. Beautiful. Beautiful. So it's the same setup as we had before, just without a total number. I've got fiber X on one end. I've got fiber max on the other. 55% fiber in one, 70% fiber in this. The metric that we're averaging is concentration of fiber. So mixture problems are also weighted averages. So the amount of the two once I meld them together would be 65. I look now for my split. So the 55 end has pulled the average 5 units in its direction, whereas the 70 end has pulled the average 10 units in its direction. So the 70 gets a 10. The 55 gets that 5. I reduce those amounts. I'm at a 1 to 2, and that's my ratio. There it is. My ratio is 1 to 2 B. That was too easy, huh? All right, let's see how this one feels. This one I expect is probably going to take a little closer to 2 minutes, would be my guess. Trying to figure out how to get it set up. I'm glad. I'm glad it does. It's going to make some of these really awful problems feel a whole lot easier too. All right, so here we are at 2 minutes. Yeah, it's like E for sure. It's got E for sure, I'm sure. So we've got an average of buildings. We've got some of the buildings that were built 2 years ago, and then some other number of buildings that were built however long ago. And the average age is greater than 40 years old. So this is very much a weighted averages problem, in the sense that I've got some young buildings. Technically, I'm going to have some very old buildings, and then where that midpoint is going to be. So let's first imagine, right, that I have, right, because there's a lot of information missing. I know that I've got 4 buildings that are 2 years old. So this is my number of years old. And I know that the average has to be greater than 40. So let's pretend at first what the easiest value would be is, let's imagine that the two groups were the same. I had 4 buildings built 2 years ago and 4 buildings built some other age ago. So 2 is whatever this is over here is pulling the average age up by more than 38 points. If they were perfectly equally sized, this thing would be equally pulling about 38 this direction. So if they were allowed to be exactly 40, right? If 40 was allowed to be the average age. So what number would be above 40 by 38? I've got one value that a 78 would be here. So if I had 4 houses that were each 78 years old, then I would have a situation where I would have an average age of exactly 40. But what I know is that none of the buildings are more than 80 years old. So I can't have that many more buildings up here, or that much older buildings up here. In fact, the oldest thing I could have up here would be like 79.99 years old, which is basically the 78 anyways. Adding that 1.5 is not very much in terms of this big weighted average. So what this indicates is that 4 is going to be the absolute lowest number of old houses I have. Right? It's the absolute lowest number of old houses. Well, so 2 years ago would make them 2 years old and then 8 years old. So I could have none or more than 80. So I could take this up. Yeah, that's a fair point, JD. I could take this up exactly to 80, which in that case would be 40 years away. But the point still stands that there's no way, right, for me to have fewer than 4 houses. 4 would be my minimum at that end, right? 4 would be none of at that end. And so at a bare minimum, my total, so if I had 4 at 80 years old, I would pull the average above 40. If I only had 3 at 80 years old, the average would end up getting pulled back to the other side of 40. And so my minimum here is 4. So which of the following could be the number of buildings on the block? It has to be something greater than 4 plus 4 or something 8 or higher, which means the first one won't work. Only the latter 2 do, which puts us in at the last one. Nice, y'all. Okay. So we're going to try how this weird thinking about pulling and pushing and weighting can play out in the world of integrated reasoning. And so we're not going to solve this individually. We're going to solve this one working together. So what I'd like for you all to do is take a moment to read over the upfront, and then we'll talk about the first statement. Yeah, JD, great question. When we're talking about the age of a building, if I tell you that something was built 2 years ago, you'd want to think about the logic of, well, how old is that building? So a building that's minus 2 years old is a building that hasn't been built yet, if that makes sense. Like the age of minus 2 doesn't necessarily have a realistic analog. But Rohan, that's a perfect point. Okay, so notice that I have this crazy table. The table displays data on Q1 sales, blah, 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 for 20 stores. Great. At this chain of discount marts. And now my job for this like table problem, I'd be able to sort. And so we're going to sort. I'm going to sort as needed to be able to answer these questions. Well, the first one seems okay. The store with the lowest sales per salesperson is store J. So how would I get the lowest? So I want sales per sales rep or whatever, salesperson. And so we'll change, this is sales rep, right? And so this is sales per salesperson. To get the lowest value for this, I would want the smallest number of sales over the highest number of my reps, of my sales reps. So I might, in this case, sort by sales reps, right? So this will be, if I sort this by sales reps, up here would be my highest sales reps. And now I want the lowest number of sales that go with them. So the lowest number of sales in this case would be the 141. And so the store with the lowest is store J. The correct answer is yes. Okay, cool. So our correct answer is yes. Excellent. So now let's look at the second one. Right, so we'll stay where we are sorted for a moment, and then we'll look at the second question. So our second question says that the average sales for all stores combined is greater than 150. Now, we discussed already that to find the average, I have to sum up and then divide by the number of terms. So if you're telling me that I have to add up all of these numbers and then divide by 20, you're crazy. I'm not going to do that. I don't have time to add up all of these numbers. I know I have a calculator. It doesn't matter though. Just because I have a calculator doesn't mean that I'm going to sit there and do this much math. And so what I've got to come up with is a faster way. So let's start first by just sorting on the number of sales. And it says the average is greater than 150. So let's remember that the average is the weighted middle. So let me see where things land in terms of 150. Well, here is a value at 150. Now, if I start to look at the over under, this one's under 2, and these are each over 1. Those would all cancel each other out. This under 2 would cancel this up by 2. So I'd be using my fingers on the screen, right? This under by 4 cancels with this over by 4. Under by 5, over by 5, over by 5, under by 5, under by 7, over by 7, over by 8, under by 8. Here's an under by 8 that hasn't been canceled yet. So these are all canceled out. That's an under by 8. Here is an over by 9, but there's the under by 9 that goes with it. And then I have an over by 22. So is my average going to be higher than 150? Yeah, because here's my 150. And I end up with plus 22 minus 8. I'm actually going to end up as a net positive over 150. The answer to my second one will be yes. So I don't have to add all of these numbers up to each other. I should not be adding these numbers to each other. I don't have the time to do such a thing. The last question says the average sales per salesperson across all stores combined is less than 70. So I do have a calculator. And so what I'll do for my last piece is just get a sense of, okay, I know that the average is over 150. And so maybe I'll just say, I could be more specific about precisely how much, but let's pretend at the very bottom edge that the average was 150. And I know that it's above that. So I have 150 is the average. If I sum that, I would find the total sum because now I want the average sales per salesperson. So I'd take the 150 times all 20 stores. And then I'm going to divide by the number of salespeople. So what I need to do at this point is come over onto my page or sort by sales reps so I can get a sense of how many sales reps I have. So I've got 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16 plus 1, 2, 3, 4, 5, 6 times 3 is 18. If we add all of those together, right? So I'll take my 6 plus 16 plus 18. I'm going to divide 150 times 20 over 40. Well, that kills that and leaves me a 2. I know that the average sales per salesperson are at least 75, so no way is it less than 70. So we can use this same push-pull of the over-under even when we're dealing with giant data sets. And yes, the tables are interactive. You'll be able to sort by the column. You won't be able to subsort though. So you can sort each one, but then it kind of resorts, unsorts the others. Yeah, great question. So we get true, true, false, right? Yes, yes, and then no. Nice. Okay. All right. So let's take this to one other, this sort of back and forth push and pull, to one other really challenging IR question type. And this is the two-part. So for two-part, often these will be asked in ways that don't allow us to solve for a specific value, but instead we're being asked to solve for something that might be jointly consistent, meaning that there is no single value for X or for Y. There's just a value for both that would make them true at the same time. Oh, yeah, I'm sorry. And Ritik, yes, I can. The idea here is that the max sales, so the number of sales, so average sales per salesperson would be number of sales divided by number of reps. And the number of sales can be found by multiplying the average times the number of terms. So the average sales times the number of stores. So that 150 times 20 is going to give us our total sales. And then we sorted and came up with our total number of representatives. And so if the max was definitely greater than 150, then at a minimum, 150 times 20 divided by that total number of reps is at least 75. Cool. All right, so give this one a shot. We're looking for two values, a value for X and a value for Y, that would make this story true. All right, start to make a guess if nothing else. I know this one is a really tricky question. That's why I figured I'd toss it in here for y'all. Doing so well today, so well. Yeah. Oh my gosh. It's like I got some giant number. I don't know what to do with this thing. All right. So here's how an average would work. Okay. Especially when we start to think about an error happening. Exactly. So imagine I had a set of numbers. Let's go with a really simplistic set of numbers. I had the numbers 1, 2, 3, 4, and 5. Okay. The current average of this set is what? 6, what is that? 6, 12, 34, and 15. So the average right now is 3, that number in the middle. But let's say we screwed one of these up and it really wasn't supposed to be a 4. It was supposed to be a 10. Or let's go with we'll stick with the 5. It wasn't supposed to be a 5. It was supposed to be a 10 instead. And so I've underestimated my average by 5. Which means I'm going to increase the sum. So if we think about the average as the sum divided by the number of terms, my new sum is actually going to be 10 higher. But I have 5 terms. So that added 10 divided by 5 is the impact on the overall average, right? So if I have an error, I spread that error across all of my terms. So this 10, instead of a 5, I've gone up by 5 points now from where I was before. So I've gone from 5 up to 10. So I've added 5. So that divided by the number of 5 terms means that my new average is going to be plus 1. All right, so that added 5 got distributed across the 5 terms, and so gave me a plus 1 to my overall average. Okay, so we're going to use this idea of where did my overage come from to solve this problem. And here's what I know. I have an average, so we'll just kind of make this, we've got, average equals, 523 equals the sum over the number of terms, 12. However, one of the shipments had accidentally been put in as 504 and needed to be something else. So if my original shipment was 504, if the accurate version of it was 520, that would mean that I'm adding 16 to the sum. That would then get divided through by 12 and add some number to my overall average. So if my original sum over 12, right, is 523, then the sum plus the fix, if you will, over 12 equals the new average. And so if you think about this for just a second, the new average is going to equal the sum over 12 plus the fix over 12. This is the original 523. So whatever the heck my fix is, whatever that move is that I had to add or subtract, whatever that fix is, once I divide it by 12, I'll add that to the original average of 523, and that would give me my new average. Here's the problem. If I add 16, that doesn't divide evenly by 12. And none of these have non-integer values. So can't be the first one. The second one would be adding 17. This one would be adding, so add to 25 would be 21, still not divisible by 12. Up to 527 would be 3, still not divisible by 12. But this one means that I would be adding an error of 24. So if I add an error of 24, that would add 2 points to my old average, making my new average 525. And so the corrected value needs to be E for a corrected average of 525, C. So how we look at this, like a little bit of overage, how does that shift or carry up my average? Nicely done. Nicely done. All right, one final exercise, and then we'll double check in on stats. So one final exercise on median, and I actually want to do this one. So we'll do one more. This is a quick one. It's either you know it or you don't. So we'll take about a minute to review it. Okay. Yeah, that was a crazy tricky question, right? I know. I know. I know. Oh. You pick one selection in each column. Yeah, one selection in each column. All right. So let's talk about this one. This will get us our understanding of median. So we know that the median is the physical middle, but what often happens is that people don't know how to handle the median when given in a visual representation like a pie chart or a bar graph. And so the thing to think about is, what am I finding the median of? I'm finding the median household size. So what I would do in this case is I would list out, like, okay, here's a one person, 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 then all the two people, and then all the three people, and then all the four people. And I'm looking for the point where 50% of the observations are on the left and 50% of the observations on the right. That means that I am looking, if I ordered them by one person, and then by two, and then by three, I'm looking for the place where I hit the 50th percentile. And in this case, I'm going to hit the 50th percentile in the near the end of my two people households, because I'll have gone 21% into 1%, and then I'll go another 36, so over the 50% mark in through the two persons. Yeah. Now, the second question requires a little bit more understanding about a concept of skew. And so here comes the quick and dirty lesson on skew. That if I have a set that's symmetric, no matter what that looks like, it could look like a normal distribution or what have you. If I have a symmetric set, then what I know in those cases is that the average equals the median, right? Everything's nice and centered. However, we know that an outlier has no impact on the median, but has a great big impact on the average. Outliers, really big values or really small values, will pull the average in their direction. Imagine that you're going along just fine, living in your happy little neighborhood, and then all of a sudden someone came in and built a $52 million mansion in your home. Or in your neighborhood? What happens to the average price? It goes through the roof. So same idea here. So in a skewed set, average does not equal the mean. And in fact, average is pulled toward the outliers. So what does that mean for our pie chart? Well, I've got a big stack of ones, a bigger stack of twos. So this is my one person household, my two people household. My three person household would be kind of like this size. 4-person household, then 5-person household gets kind of small. And then 6-person, 7-person, and so on. So I have a skewed distribution. The median will sit here. The average will get pulled higher. So I don't want to calculate the average. I don't want to go through and run a bunch of numbers on this mess. No, thank you. That sounds insane to me. Right? Absolutely insane to me. Yeah. Okay. So no, we don't want that. We don't want to do all the math. We're looking for opportunities to not do all the math. So speaking of, though, all the math, let's just make sure that you're armed with the 3 basic concepts of standard deviation. First, the spread. How comfortable do you feel putting these in the right order? So from highest standard deviation, which of these has the highest standard deviation? Which has the highest standard deviation? Yeah, the most spread out one is going to be our highest. So this will be the highest. We'll call this number 1. Right behind that, we'll follow with D. We're getting more and more compressed. 3. And then our last one, the lowest, and I'll just call this lowest. This is the only standard deviation we actually need to know. That has a deviation of 0. All right, what about number 2? What is the answer to question number 2? Nice, y'all. So good. Yes. So I would take the average, 9, and I would add 2 deviations. So I'm going to take 9. I'm going to add 6.5. And get myself 15.5. Perfect. Okay, what about the last one? Last but not least. Last but not least. So the last lesson we need for standard deviation in terms of like the fixed rules is that adding or subtracting to a set of numbers doesn't change its deviation. So for example, if I change this set by adding 10 to every term, 11, 12, 13, 14, 15, my spread has not changed. Standard deviation is left unchanged. If I multiply all of these and instead of 1, 2, 3, 4, 5, I triple each of them, and now I have 3, 6, 9, 8, by 3. 3, 6, 9, 12, and 15. Now notice that my set went from going just from 1 to 5 or 11 to 15, now from 3 all the way to 15. So if I multiply or divide, I have to do that exact same thing to the standard deviation. So in this case, adding 4 didn't do anything, but multiplying each value by 1.5 means that I'm going to take the original standard deviation. I will also multiply it by 1.5. So my new standard deviation is 3. All right, so since I promised you a data sufficiency, give it a shot. Right, so here's your data sufficiency question up front, your 2 statements, and your 5 answer choices. Timer going for you. That's a perfect one, Rohan. Yep. The more elements you can add in closer to the average, the better. The more elements that get added further away from the average, the worse for your standard deviation. Mhm. Better meaning it makes your standard deviation smaller. Yeah. So, is it true that a larger range equals a larger standard deviation? No, but for the purposes of the GMAT, yes. So you can use range as an indicator of standard deviation. It's directionally accurate, but in the real world, no, because we actually also care about what's happening inside of the set. So I can have a set that has a crazy big range because of one big outlier, but the rest of the set is all very clustered. Whereas I could have a second range that doesn't have that one outlier, but all of the values are the furthest they could possibly be from the average. And I could end up with a higher standard deviation. So the GMAT's not going to do that to you, though, because it knows you don't have Excel and a calculator. You will never compute standard deviation for a set. Ever. Never. Never. Even in the real world, you would never compute standard deviation by hand for a set of more than like 3 or 4 numbers. And you would only do that if you were taking like a theoretical stat or econ class. You would never, never do that by hand or with just a calculator. Or I'll be honest, even with Excel, you would use a function. All right, I love it. I love the answers coming in. I love all the questions. Y'all are on it today, is all I can say. Like on it. And so where did my little page go? Oops. So let's talk about this one and how we can get to, let me get a little bit of space so that I can work on this would be nice. Here we go. So let's talk about how to organize this one. So up front, we're being asked about standard deviation. I think the thing you really want to walk away with standard deviation is that 9 times out of 10, you are asked about the conceptual understanding of standard deviation, like how spread out are things. Yeah. And so set M contains 7 consecutive integers. So I don't know what those 7 consecutive integers are. I'm just going to kind of I'll make a little line for each one. Like here's 1, 2, 3, 4, 5, 6, 7. Great. There's 7 of them. That's set M. Now set N is going to be to select 3 values from them. And I want to know, is the standard deviation of set N bigger or smaller than set N? And really what I'm trying to figure out is, am I picking values for set N that are really close together, or am I picking values that are really spread out? So that's kind of it, is that I want to know how close are my N values to each other. Because if I pick values, let's say out here, like I pick 1 out here and 1 out here and 1 out here, that is going to be a very bad standard deviation. If, however, I pick 3 values together, and it doesn't matter where, like these 3 together, or even these 3 together, that'll be more clustered. It's a smaller set of numbers with a tighter standard deviation. And so I want to know how spread out my set is. So if set N contains the median, it could be that it contains the median and a clustered set of values. It could also mean that it includes the median, but then 2 very broad values. So knowing the median doesn't tell me how clustered a set is. And so this would be not sufficient. Statement 1 does not give me enough information to even figure out what the standard deviation of this set would be. Right? It's too spread out. Right? It could be very spread out, it could be not spread out. Okay. So that statement 1 will get rid of answer choices A and D, since statement 1 is not sufficient. Statement 2, however, says that the range of M and N are equal. What that means is that with only 3 values, I'm going to have a set that either has, one way to the left, one way to the right, and then I could have 2 over to one end and 2 on the other, or I could even stick this one into the middle. But the point is that I have now a much worse set. I have fewer numbers, but in general, my values are on average further away, no matter where I put it. No matter where I put this center value, I'm going to end up with a set that has a worse standard deviation than the original, because all of the positive helping pieces are gone. And so, in fact, statement 2, because it tells me that set N is more spread out than set M, set 2 is sufficient. N has a deviation greater than M. I don't need the 2 together. The correct answer is, in fact, B. I only needed to know that the range is greater in this case because I'm having to pull one set from another. So I only need to know statement 2 tells me that M has more holes in it, is more spread out as a general rule than M. I know. It's hard, right? This is hard. Okay. So mixing statistics, right? Like, does knowing the median give me the standard deviation? No, it didn't tell me what it was. Does knowing the range tell me the standard deviation? No, but it can be a little bit directionally accurate, only because I have now combined that with the concepts of consecutive integers and that I'm picking a subset. In general, what I want you to note is that knowing something about one statistic tells you essentially nothing about any of the others. Okay, this is the only exception, is that like loose connection between general accuracy of range and standard deviation. Otherwise, knowing one doesn't give me the others. So let's give this as kind of our capstone, see if we can recall some of the lessons from earlier in our session. And then I'll give you all a discount code. Let's do discount codes. All right, so give this one a shot. And then we will close up for the day, for the evening, I guess, for many of you. I'll set a timer going for you. One last DS. Here we go. Answers starting to come in. Answers starting to come in. All right, so let's make a little space. Hopefully y'all recognize this is a weighted average. I got sample A, I got sample B, and I got combined. So if I go all the way back to the start, sample A, sample B. So the average length of sample A is 2.4. The average length of the two combined is 3. So somewhere here in the middle is 3. And the question is the average length in sample B greater than 3.6? So on this side, 6. It's asking, is this more than 6? So really, it's which of the two groups is bigger is what we're looking for here. Which of my two groups is bigger? Because if they're both equal to 6, if they're the same size, sample A and sample B, then the average of 3 would imply that sample B has an actual average of 3.6. If there are more in B, right, and so on, right? So what we're looking for is to figure out just that ratio of the two. And statement 1 is going to give me that. Statement 1 gives me there are more earthworms in sample A. So if there are more earthworms in sample A, I could call it like 2-to-1 or 5-to-4, whatever I want. I know that the 3 is closer to the 2.4 than it would be to the B. And so in this universe, so if there's more here at 2.4, and this is 3.0, then this difference of 6, this side has to be more than 6. So this has to be more than 3.6. So sufficient. That gets rid of choices B, C, and E. That said, knowing about median, knowing about range, knowing about standard deviation, none of those things would help me here. So the cautionary tale is, typically with the world of data sufficiency, if I want to know like average, telling me median or range or even standard deviation, likely not going to get me there. The only exception is when we start to look at that kind of like loose connection between things like standard deviation and range. And that's only because that previous problem included even more additional information. It included information on whether one set was a subset of the other, and it included information on consecutive integers. So without a ton of information, I can't move from one metric to another. I can't move from median to average. I can't move from range to median, and so on. And so not sufficient for my second one. Oops, not sufficient. Oh yeah, so solving this second one, you mean, with the weighted average formula? Sure. Basically what you would do is you would say, I know that there's more, so I would have to make some new variables, which I wouldn't want to do. But basically I would say A is greater than B. So A would be the number. So I would say A times 2.4 plus B times unknown, right? Like a value, divided by A plus B equals 3.0. Like I could do that, but now I've got 3 variables running around and having a heck of a time trying to figure out how they relate to one another. So I'll argue, no, I would probably not do them that way. Right? I could set it up, but without the visual, and that's the beauty of this weighted average visual, the visual is going to let me get to solutions even when it would seem like there's not enough information. Right? Because I can start to see like, look, I don't have the actual numbers, but I do see the relationship between these values, that it's certainly going to pull to the right. I don't know what the values are that would go there, but I know that it's going to be pulled in that direction. Yeah, for sure. Now, there was one other question that came in the chat window, and this was much earlier, and I do want to highlight this. And the question was, if one person is a speed question, if the average speed going one direction was 50 miles per hour, and the average speed going the way home was 60 miles per hour, and let's say the distances are the same, so distance 1 equals distance 2, right? So this is average 1 and average 2, and the distances are the same. Why is the average speed not just 55? And a lot of people will say stuff like, well, it's just because speeds aren't an average. That's not a weighted average. That's a lie. Speeds are a weighted average. But does anybody know what the weight is when we're looking at speed? what is the weight in this case? So if this is there at 50 miles an hour, and this is home at 60 miles per hour, it's time. It's weighted over time. So if they traveled for 2 hours at 50 miles an hour and for 2 hours at 60 miles per hour, the average speed would in fact be 55 because the times are the same. So what I can do if I want to estimate weighted speed, so the average speed, is I say if my distances are the same, I know that I have more time at the 50 mile an hour because I'm going slower. Right? I'm going slower, so I take longer, so my average will be pulled towards the 50. So what I can do is estimate that weighted average by saying it'll be a little less than the midpoint. Now, here's the real cheat for weighted averages when it comes to speeds, is that the distances themselves never matter. So if they give you a distance, you can use it, or you can even make up your own. And if they don't give you a distance, just make up your own. So for example, let's pretend that the average is 30, let's go something I can do 50 miles and 60 miles in. Let's call it 300 miles each way. So my average speed is total distance over total time. In this case, my total distance would be the 300 miles each way, so 600. My total time would be the 6 hours on the way there and the 5 hours on the way back. So 6 plus 5 is 11. So I've got 600 over 11, which is the same as 550 plus 50 over 11, which is 50 plus, so 550 divided by 11, and 50 divided by 11 is 4 point, right? So I could kind of extend it further. I'd call this 550 plus 44 plus 6 over 11 is 11 goes into 550 50 times, 11 goes into 44 4 times, and about a half. So my answer is going to be about 54 and a half is where the actual, I think it's like 54.54544 if I recall. No. Well, and that's the thing, is that it's because a rate is already kind of an average over time. But again, you can use this weighted average concept to just recognize that the average of my rates is that over time. So if my times were the same, Rohan, so if I had said I traveled for 2 hours and then I traveled for 2 hours at each speed, it would be the straight center average. I could take the average of the two speeds. I can take a weighted average of speeds. I just have to know that the weight isn't the distance. The problem is that people try to make the weight the distance. The weight is the time. Yeah. All right. Friends, thank you for sticking around forever with me. Oh my gosh. Y'all are amazing. Amazing. Let me just say, amazing. Once again, my name is Whitney, and I am pumped to have gotten to spend the evening with many of you. Reminder, if you didn't know already, go to our website, manhattanprep.com, sign up for a free starter kit, and you have access to practice GMATs. You could take a GRE practice exam. We have all kinds of resources for EA, right? Tons and tons. You can also look for us on our YouTube channel. We do tons of free prep hour. Tons. And I know that we've done several of these events with GMAT Club, so you can find us there as well. And just for showing up today, you have access to a discount code that can get you $75 off the price of any course. That said, you can always attend session ones of any of our full courses for free. So if you have questions and you want to learn more about GMAT or GRE, you can always attend a session one for free. Just come hang out with us. Go to our website. You can find things on our website under our free events page. So go under the site, pull down the little calendar. You can find our free events page. We have all kinds of stuff. We have free prep hours. We have free session one trials. We have free workshops on things like procrastination and building out a calendar. We've even got free workshops with MBA Mission to help you with all of your admissions questions. So come hang out with us. It's so fun to get to spend time with y'all. That's why we do it for free, because we want to see more of you. All right. Well, friends, it has been a lovely, lovely Monday afternoon for me. Hopefully a lovely Monday evening for many of you. It was a pleasure to work with you. Again, my name is Whitney, and hopefully we'll see you around soon. Thanks, GMAT Club, for having us.